Welcome, everyone. Okay, before we do anything else, I literally just want to take a second to say massive congratulations. To all of you college students out there, you have officially made it to the very last explainer of your entire human nutrition course. Yep, this is it, the grand finale. Seriously, I have to acknowledge all the incredible hard work you've put in this semester. I mean, you've tackled some seriously complex stuff: metabolic pathways, macronutrients, vitamins, the whole shebang. But right before you officially cross that finish line and celebrate, we've got one final, incredibly practical topic to cover together. Okay, let's dive into this. So you literally just wrapped up the explainer on food additives, right? Well, that actually sets the stage perfectly for what we're talking about today. Because believe it or not, the FDA regulates bottled water as a food product. It's wild, but it means bottled water has to follow some very similar strict guidelines. We're talking specific labeling requirements, especially when things like added flavors are involved. So here's our definitive roadmap for this final stretch. We're going to cover EPA versus FDA water rules, tap versus bottled water, the Flint water crisis, emergency water storage, and finally, sanitizing compromised water. Let's keep that energy high. This is exactly what stands between you and the end of the semester. All right, let's jump straight into Section 1, EPA versus FDA water rules. Now, what's really interesting here is how this whole legislative division actually breaks down. When you look at tap water, that falls under the Environmental Protection Agency, or the EPA. They're the ones setting those rigorous hardline standards for municipal water supplies, clamping down on the maximum allowed levels for dangerous pathogens and nasty chemicals like lead or arsenic. But on the flip side, we've got bottled water, which is governed by the FDA. And while their standards are generally pretty similar to the EPA's, remember, they treat bottled water as a food product, so they require all that food-style labeling, particularly when any kind of flavoring is introduced. Moving right along to Section 2, tap versus bottled water. So, fun fact for you. Did you know that bottled water is currently the #1 most consumed beverage in the entire United States? It's true. It has completely blown past both milk and juice in popularity. But here's where we need to shatter a pretty massive misconception about where all that popular bottled water actually comes from. The crucial point is that a lot of these products have municipal origins. What does that mean? It means they are literally just municipal tap water that has gone through a little extra filtration. That's it. The FDA's safety standards for bottled water are closely modeled right after those EPA standards for tap water we just talked about. It's essentially the exact same foundational standard. Let's just weigh the trade-offs between the two. Bottled water obviously offers fantastic convenience and, for a lot of people, a preferred taste. But it is significantly more expensive. And on top of that, and this is a big one for long-term health, bottled water generally completely lacks the fluoride that gets intentionally added to public municipal tap water supplies to help promote dental health. Shifting gears to Section 3, the Flint water crisis. We've talked about regulations and personal choices, but we absolutely have to look at what happens when these municipal safety nets just completely fail. And this tragically illustrates the 2015 Flint water crisis. Walking chronologically through this massive structural failure, first, the city switched its main water source to the Flint River. Second, they totally failed to use proper anti-corrosive treatment on that new supply. Third, because they skipped that treatment, lead from the aging municipal pipes literally leached right into the drinking water. And fourth, this led to widespread lead poisoning. The devastating part here is that lead poisoning carries permanent neurotoxic effects, which are especially harmful to developing children. It is just a stark, real-world reminder of exactly what's at stake with municipal oversight. Which brings us to Section 4, emergency water storage. Because public systems can absolutely be disrupted by infrastructure failures, like what we just saw in Flint, or by natural disasters, we really need to pivot to personal empowerment. Let's rapidly fire off some highly practical rules for your own emergency prep at home. You're going to want to store at least 1 gallon of water per person per day to last you a minimum of 3 to 5 days. Keep all of this stashed in a cool, dark place, using sturdy plastic bottles with really tight lids. But here's the absolute most important maintenance step. You must change that stored water out every 6 months. Doing that prevents the plastic from degrading into the water and ensures it's actually fresh when you desperately need it. And finally, Section 5, sanitizing compromised water. Okay, so what happens if your public supply is cut off and your personal storage just runs dry? Before we get into exactly how to treat compromised water, I have to deliver a very quick, very crucial warning. Most standard filters do not remove all viruses, so relying solely on that basic pitcher filter sitting in your fridge right now, yeah, that's simply not going to cut it in a true emergency where the water is dangerously contaminated. Let's move to the actual solutions and see how this builds your personal survival toolkit. We've got 4 primary sanitizing methods here. First up, boiling. This is the absolutely most effective way to kill pathogens. The golden rule is 1 minute of a rolling boil, but, and this is a big but, pay attention to your altitude. If you are up above 6,562 feet, you've got to boil it for 3 full minutes. Next, we have chemical tablets like chlorine or iodine. These work great, but you have to follow the strict ratios on the packaging to avoid any dangerous chemical toxicity. Then, there are portable UV light units. These are awesome for small amounts of water, but keep in mind they are completely useless if the water is cloudy or turbid because the light just can't penetrate it. And lastly, distillation. This is where you boil water and collect the resulting steam. You'd use this method specifically to remove things like heavy metals and minerals that regular boiling just leaves right behind. Now, even in the absolute most desperate emergency, there are some sources that are just strictly off limits. We're talking untreated surface water, like streams or random lakes. But also, please, do not try to drink from radiators, swimming pools, or waterbeds. These things have incredibly high toxic chemical contents. And honestly, if you are genuinely considering drinking tepid water out of a vintage 1980s waterbed, well, things have definitely gone terribly, terribly wrong. Which brings us to the very end of our time together. I want to close out this entire human nutrition course with one final, thought-provoking question for you to ponder. If your tap ran dry tomorrow, are you prepared to safely hydrate? Take all this incredible knowledge you've gained this semester, from how your body processes vital nutrients to how you can actively protect your own water supply and use it to live a healthier, safer life. Once again, huge congratulations on crossing that finish line. It's been an awesome ride. Stay curious and take care.